Alrighty, the last page of the review. Number 24 says Mr. Margot is 15 feet away from a flagpole. The angle of elevation from his feet to the top of the pole is 39 degrees. And there are two parts to this problem here. You have to draw a picture of the scenario above, and you have to include the measures as well. So I'm going to go ahead and draw Mr. Margot. And there is a flagpole. So Mr. Margot is indeed 15 feet away from the flagpole. So from Mr. Margot's feet to the flagpole, or the bottom of the flagpole, we got 15 feet. So I'm going to label this 15 feet here. And then the angle of elevation from his feet to the top of the pole is 39 degrees. So this is my horizontal line of sight. I shouldn't make this a solid line. I should make that a dashed or a dotted line here. So this is my horizontal line of sight, and then since it's an angle of elevation, I am going to go up. Okay, so that's going to be at, again, 39 degrees. Okay, so we have A done. And it says for B, it says determine how tall the pole is. Do we know how long or how tall the pole is? Absolutely not. We're going to call that our unknown, or our X value here. So we're going to call that X. And that's great. I have my angle of reference, and I have these two sides here. So I can go ahead and apply trigonometry. So I write SOHCAHTOA up top. I see that I have, what do I have here? I have my opposite side. This is my adjacent side, and this is my hypotenuse. Notice that the opposite side and the adjacent side are given. So that means I'm going to apply tangent. So I write tangent of your angle of reference, which is 39 degrees, which is equal to opposite over adjacent, or X over 15. Notice that 15 is in the denominator, so I am going to multiply both sides by 15. So I have 15 times tangent of 39, which is equal to X. I'm going to go ahead and put that in the calculator right now. So I have 15 tangent of 39. And that's going to give me, if I'm going to round to the nearest hundredths here, it's going to be 12.15 feet. And that's your answer. Number 25, Mr. McGrath is on top of a tower of height 20 meters. So I'm going to go ahead and draw my tower. It's going to be a weird looking rectangle. This is my tower, and Mr. McGrath is up top, and the tower itself is 20 meters long, and Mr. McGrath is 6 feet 2 inches tall. Assuming that he is. So this is the tower, and this is McGrath. So I'm going to go ahead and include his measurement. So it's 1.9 meters. So luckily this here is converted into meters. That's great. So I have 20 meters in Mr. McGrath. So that means I can go ahead and add those two measurements there. So I have 20 plus 1.9, which is 21.9 there. And what does it say? He observes the angle of depression of a ball lying on the ground at 60 degrees. So there's Mr. McGrath. That's where his eyes are. Draw your horizontal line of sight. And since it's an angle of depression, you're going to be looking down. Okay, so there are the dashed lines. This is the horizontal line of sight, and we're dealing with an angle of depression, so he's looking down. So this angle here is going to be what? Do we know how long the angle is? 60 degrees. Okay, so I'm going to put 60 degrees right there. What else? I have my picture drawn. It says find the distance between the base of the tower and the ball, which is right here. So then I should have a wonderful right triangle. Let's call this side here X, because that's my unknown. Okay, so that's my unknown. So if this here is 60 degrees, that means that this here is also 60 degrees, and that's because of alternate interior angles. okay? So now that I know what this angle here is, and we can see that I'm dealing with a right triangle, that means I can go ahead and start labeling the figure. So this is my angle of reference. So this is the opposite side, this is the adjacent side, and this is the hypotenuse. So the given values are, well, I'm sorry, this should be over here. So the given values are 21.9 and x. So I have opposite adjacent, yes? So I write tangent of 60 because, again, if I write SOHCAHTOA up top, that's your best friend. I have opposite adjacent, that means I'm using the tangent function. So tangent of your angle of reference, which is equal to, or sorry, tangent of 60, which is equal to 21.9 over x. Notice that x is in the denominator. That means I'm gonna go ahead and swap with a tangent of 60 right there. So that's gonna be x equals 21.9 over tangent of 60, okay? So 21.9 divided by tangent of 60, that's gonna be, what am I rounding to? To the nearest hundredths? That's gonna be approximately 12.64 meters. 12.64 meters, okay? So that's number 25. Number 26, due to a storm, a pilot named Miss Lake is flying at an altitude of 625 feet. She needs to land if she has a horizontal distance of 3,500 feet to land. At what angle of depression should she land? Round to the nearest hundreds. Okay, so this is the pilot. So you need to have your horizontal line of sight first, yes? And then we're dealing with an angle of depression, so she should be looking down. She should be looking down, okay? So luckily this is all drawn out for us, but please make sure you know the difference between the angle of elevation and the angle of depression, and be sure that you draw your horizontal line of sight, okay? Because if we didn't have this horizontal line of sight, a lot of students will make the mistake and say that the angle of depression is right here. This is wrong. You need to make sure that, again, draw your horizontal line of sight. When you're looking down, this is the angle that you are looking for, okay? So this is the angle of depression, which is a question mark. That's our unknown. Now, notice over here it says we have a horizontal distance of 3,500 feet, right? So from here to here, that's horizontal, right? So that's parallel to this. So if this is 3,500, this is also 3,500, and they are above 620, or sorry, the altitude is 625 feet, so that's already labeled for us too. So really what I want to do is I'm just going to focus on this triangle, this right triangle here. This is my angle of reference. It's a question mark, so I can go ahead and label the figure opposite. This is the adjacent side, and then this is the hypotenuse. So I can write SOHCAHTOA. And what are the given values? I have 625 and 3,500 feet. So I'm using tangent. So tangent of, let's call it the question mark. You can call it X or whatever you want, but still it doesn't, change anything. Tangent of your angle of reference, which we call the question mark, is equal to the opposite side over the adjacent side. So it's 625 over 3,500 feet. Now, I'm solving for the angle, right? If I'm looking for the angle, if it says, what is the angle of depression, or what is the angle of elevation, or what is the angle measure, you're basically going to apply the inverse trig function here, right? So you're going to press second, and then the appropriate trig function, which we are using tangent. So second, tan, then you're going to input that fraction, 625 divided by 3,500. And what are you going to get? Well, this question mark in degrees is approximately 10.12 degrees. And that is your answer. Okay? And then I want to make sure I'm clear with Mr. Margot's picture. So you have to have the horizontal line of sight drawn first, Then, since we're dealing with an angle of elevation, you should be shooting up to the top of the flagpole. So this is the angle of elevation. I wasn't sure if I was clear enough with that first example, but what I'm trying to say here is when you're doing the word problems, find what type of angle you're dealing with. Angle of elevation or angle of depression. Draw your horizontal line of sight first, and then if it's an elevation, it should go up. If it's a depression, you're going to go down, okay? So please make sure that you keep that in mind. And this is basically the last part of the review, so I am done.